So in FRQ4, you know, this is the last one that you're going to do, so that can be, you're going to be tired. It's the end of the test. You're almost done. And shh. Oh, you should have it. What do you mean? So we are solving g of x and h of x. This is exactly what I was talking about. G of x equals 3. I'm going to plug in 3 for g of x, okay? And I'm going to solve. So I have log base 4 of 2x equals 3. Shh. And then I'm going to solve it, okay? So to solve a log equation, I rewrite it in its other form. That is 4 to the third equals 2x. Now, no calculator, so 4 squared is 16, and 16 times 4 is 64, okay? Half of 64 is 32, okay? Stop me if you have a question about anything I'm doing. Okay. In the second one, we have a exponential function, e to the x to the 5th over e to the 1/4. That was given, and then it says solve for e to the 1/2. So we have to remember our exponent properties. When you see a power to a power, we're going to multiply that. So that's going to be e to the 5x. And then using our quotient property, we keep our base, subtract our exponents. So x times 5 is 5x minus 1/4. That makes sense? So whether these were e's, x's, 7s, you keep the base, subtract your exponents. And then if you remember, whenever your bases are the same, e equals e, or 7 equals 7, or log base 5 equals log base 5, if the bases are the same, you can just set the exponents equal to each other and solve there. Because if e equals e, that equals that. Okay? And so then I would add 1/4 to both sides. Again, I'm not using a calculator, but we have practiced a lot this year, especially in the trig unit, finding a common denominator. Not that you have to show this step. I think a lot of you know that that's 3/4. And so to find a common denominator, this would be 2 times 2, 1 times 2. That would be 3/4. And remember, I did an example of this on that pink sheet. You want to get x by itself, you're dividing by 5. Dividing by 5 is the same as multiplying by 1/5, which makes more sense in this question. And you get x equals 3/20. Okay? And we're not boxing our answers. It's really hard for me. I have to like hold my hand back from doing this. I like to do that, but we want to not do that. Okay? And staying in the borders of the answer sheet. Okay. These two problems, let's start with B1. Rewrite j of x as a single log, base 10, without negatives, negative exponents in any part of the expression, and your result should be in this form. It's telling you exactly what your answer should look like. Log base 10 with some stuff in parentheses. Okay? So, log base 10 of x plus 1 minus 5, log base 10 of 2 minus x plus log base 10 of 3. Now, that looks pretty gnarly. It looks like it's really hard. It's really not, okay? Let me remind you what you're trying to do. You're taking 3 logs written all out and trying to condense it down to one single log. So, and as we know, our final answer is going to be log base 10 of something. So then when I look closer, I notice this subtraction symbol. I notice an addition symbol. These are coming from your properties of logs. Remember, subtraction goes with division and addition goes with multiplication. So that's your quotient property. This is your product property. And then we also have our power property, which says that a coefficient, leading coefficient number in front of the word log can be rewritten as a power and vice versa. It can toggle back and forth. If it was up there, we could write it down in the front. So I'm going to start by just writing log base 10 once, and then I would have x plus 1 in my numerator. Okay? Minus and division goes together, so I'm going to make myself a fraction, and I'm going to put this guy in the denominator. This guy is 2 minus x to the power of 5. Does that make sense? That takes care of the first 2 of 3 logs. Careful here. This says times 3. I feel like the instinct would be to put the 3 in the denominator, but that, if you were going to put the 3 in the denominator, this would be a minus. It would mean dividing by that. This is multiplied by 3. Like, you wouldn't write this, but 3 over 1. Think about it. You're multiplying by 3 over 1. Okay, so it's really in the numerator. To write my final answer, so I'm going to put my parentheses or brackets, I would have 3 x plus 1. Could you distribute? Yes, you could. Okay, so it's 3 times x plus 1, or distribute it, over 2 minus x to the 5th power. No negative exponents in our answer. We have log base 10 of 1 expression. That's all you had to do. See, that's not bad if you remember your properties. Is that good? Yeah. And it's funny, I thought that was interesting that they put the 10 there. You guys all know that log base 10 is just your common log of base 10. I'm surprised they wrote it there. I don't think that that would be wrong if you left it off, but if they included it, I would just say, just to be safe, you know what I mean? But I would be very surprised if they didn't give you the point because you left off the 10, because that's what it means. Okay. This next one, rewrite k of x as a product involving multiplication, tan and sine. So somehow our final answer, we have to go from this to sine and tan multiplied together, okay, with no other trig functions. Can't have cosine or secant or anything else in there. And these are the ones you guys liked the least this year, I would say, overall. This came from section 3.12, if I remember correctly, where you had an open note quiz and you had to verify it. It's like a proof, and it had like the other side. We're not giving you exactly what it's supposed to look like. We're just giving you a hint. Or we have to change this somehow with our identities to make it look like sine and tan multiplied together. So these are the problems that make some of us uncomfortable because we don't have a whole plan. You guys can look at an equation. You can stop right here. All of you can tell me exactly what the next few steps are. You know exactly how you're going to solve this. I'm going to do 4 to the 3rd power, then I'm going to divide it by 2. And we could make this a much longer equation. You could all say, oh, I have to distribute, then combine like terms, and I'm going to do this, and you can make the whole plan. With these, it's much harder to do. I'm good at these, and I don't have a plan always, okay? I just do one thing. And one thing I know I can do is change anybody that's not sine and cosine to sine and cosine, okay? So I'm going to change my secant to its reciprocal function of 1 over cosine. Remember, secant goes with cosine, and sine goes with cosecant. All right? And really, I don't know what else to do with this except combine them into one fraction. Remember, my final answer it didn't say write your answer as the difference of two things. It said product. That's multiplication. So somehow I've got to get rid of that subtraction. So let's subtract them, which means I need a common denominator. Cosine and 1, their common denominator would be cosine. I'm not changing this fraction at all. Just leave it as a 1, bringing down the minus. This fraction needs this as its denominator, so I'm going to go ahead and multiply that denominator by cosine, the numerator by cosine. So cosine times cosine. Make sure you write this correctly. We're looking for proper math notation. The squared, even though it feels weird, goes on the word, not the x. Cosine squared x. And that numerator now should ring a bell, I hope. Anybody remember what 1 minus cosine squared x equals? Sine squared x, right? 1 minus cosine squared x equals sine squared x over cosine x. Okay. I'm still not at sine and tan. I can rewrite that numerator as two signs, right? Sine squared is sine times sine. And I can put cosine under one of them, but not both. Remember, whenever you're not sure, check it going backwards. If I started here and I actually multiplied these together, would I get this? The answer is yes, right? If I put a cosine under here erroneously, I would have had a cosine squared here. Okay, so you can't go from cosine to cosine squared. All right, and then remember what sine x over cosine x equals? It equals tan x. And this could have been written in any order. Tan x, sine x, tan x. Danielle, feel okay about that? All right, and the last one's probably the worst, and I think this is a little bit harder than you might see. And starting with the directions, part C is the same as part A. It's just written in another language. It's like translated. The function m is given as this. Find all input values. Input values are x. Find all the x's, x values, in the domain of m that yield an output value of this. Output is y. So it's the exact same question. Here's my equation. Plug sine, inverse sine is blah, blah, blah in here and solve for x. Okay? So I'm going to write 2 tan 3 equals inverse sine. Okay? So first thing I notice is I can simplify this side. Remember, anytime you see inverse sine, that is asking for the angle. This is the exact value. We want the angle where this happens. And where in quadrants, remember with inverse sine, we're only dealing with quadrant 1 and quadrant 2. Where in inverse sine, where in those two quadrants do I get a sine value of the square root of 3 over 2? And that is pi over 3. So I just simplified that side to pi over 3. I'll make this real quick. Okay. Then I'm going to start trying to peel everything away from x. Remember, our goal is to solve for the input values known as x. Divide by 2, divide by 2. Pi over 3 divided by 2, keep, change, flip. So we're really multiplying by 1/2. That would be pi over 6. Good, Danielle? This is the kind of a tricky part. How do I solve for x? I want to do something with this inverse tan. And it's kind of like if I asked you, what could you multiply x by to cancel it out? It would be 1 over x. Or what could I multiply 1 over x by to cancel it out? It'd be x, right, to get just like 1. Same idea. I'm going to multiply inverse tan by tan. They cancel each other out. But if I multiply this side by tan, I have to multiply this side by tan. Notice pi is not under the radical. So all we are left with on this side is what was in the parentheses, and tan of pi over 6. What is tan of pi over 6? This is why we want to know our tan tricks. All of our denominators of 6 are square root of 3 over 3. Is that what you said? Yeah. And then last step, we're there. We have to get x by itself, so we'll divide both sides by the square root of 3 pi. And x equals, oops, no, sorry, why did I do that? Let me fix this side. So we're dividing by the square root of 3 pi, so we're dividing this side by the square root of 3 pi, which is the same as multiplying by the reciprocals, the reciprocal. Okay, so dividing by the square root of 3 times pi, since it's a fraction over here, I'm multiplying by the reciprocal. And the square root of 3 and the square root of 3 cancel, so we're left with 1 over 3 pi. A lot going on there.
seem a little easier?